Good afternoon, dear friends. Welcome back to the last part of this chapter, Law of Conservation of Mass. My simple question, first of all. Dear friends, how are you all? Yes, I'm asking my question to all the divisions A, B, C, D. Also, I'm asking my question to the same students, roll number 1 to the last roll number of your class. So, firstly, I would like to wish you to give one chemistry clap. Yeah, ready. 1, 2, 3, 1, 2, 3, 1, 2, 3. Yes. So, you all are fine. Good. Stay home, stay safe, follow the rules, regulations, everything, and take proper care, dear friends. Yes, let's move to the last part, law of conservation of mass. Law of conservation of mass. So, if suppose I take 40 grams of ice, 40 grams of solid ice, and add it to 50 grams of water, add this ice to 50 grams of water, stir it well. And now what will happen? The ice will slowly start melting in this water and a liquid state will be formed entirely. And now this 40 grams of ice plus 50 grams of water, if we measure them totally, it will be 90 grams. So dear friends, what is that? 40 plus 50 are the reactants and the product formed is water, 90 grams. So 40 plus 50 is the reactants, that is 90 grams. The product formed is also 90 grams. In the same way, this was example of a physical change. Let us see one example of a chemical change. Physical state change, only the state of matter changes. The rest thing composition remains same. Chemical change, the composition of the substance changes. A new substance is formed or new substances are formed. That's a chemical change. Let us see one example of a chemical change also to study this law of conservation of mass. A reaction of NaOH plus CuSO4. This is a double displacement reaction. NaOH plus CuSO4, you will get the formation of CuOH twice and Na2SO4. Na2SO4. So the reactants are this. NaOH and CuSO4 are the reactants and CuOH twice and Na2SO4 are the products. Out of this, the downward arrow over here indicates that a precipitate is formed. What's a precipitate? A material that does not get dissolved in the reaction mass, is not soluble in the reaction mass. It settles down very slowly as a solid material, is called as precipitate. We are going to see one practical related to this also, how a precipitate is formed. So in this reaction, NaOH plus CuSO4 gives CuOH twice plus Na2SO4. So over here what happens, the mass of the reactants NaOH plus CuSO4 will be equal to or is always equal to the mass of the products formed. Mass of the products formed. That means over here, the mass of the reactants taken is always equal to the mass of the products formed. Maybe a physical change or maybe a chemical change. The mass of reactants taken is always equal to the mass of the products formed in all the reactions. Next example, yeah, your basic question, sir, what about burning of wood? When we take a wood, suppose if I've taken 1 kg of wood and if I burn it, the ash remained will be just 50 grams, sir, or 100 grams, sir. 1 kg of wood is burnt and the ash left behind is just 50 or 100 grams. So where has been the remaining mass? So the remaining mass is given out in the form of water vapors which were present in the wood. Then carbon which is present as the burning part of wood is also given out in the form of CO2 and CO. So all these gases are also considered, and if we consider the total mass of that ash which is left behind, then the total mass of the gas which was given out, and if we add all these 3-4 figures, you will find that the total mass of the wood plus oxygen that was required for burning, both of them will be considered. Wood plus oxygen that was required for burning, both of them will be considered. Their total mass is considered, which is equal to the mass of ash formed plus mass of all such gases, CO, CO2, water vapors which were given out. So over here also during burning, the mass of reactants is equal to the mass of the products formed. Okay, the same one example to a seed, 5 grams of seed. When you supply some water, minerals, it will absorb that, isn't it? The plant will grow, it will take the sunlight, and when we consider all this energy it will be equal to the weight of the complete entire plant. The minerals absorbed, the sunlight, the water absorbed, all this mass will be equal to the mass of the tree, and therefore we can derive the law of conservation of mass. Any one of you, please, if you can read the law of conservation of mass, or by taking these examples, can you frame this law of conservation of mass? Yes, if you are going to frame it, it will be really very nice of you all. Good. So yes, surely, good. I'm happy that you are able to frame it. So what is that law of conservation of mass? It states that matter is neither created nor destroyed in any physical or chemical change. Let any reaction take place, physical reaction or a chemical reaction. Matter cannot be created nor be destroyed. Only we can change the form. We can change the form. Is that clear to you? So that means the total mass of substances undergoing a physical or chemical change will always remain equal to the total mass of the substances or the products which are formed after the reaction. Okay, the total mass of the reactants in a reaction will be always equal to the total mass of the products formed after the reaction. And this is nothing but the law of conservation of mass. You can write this in your own words, dear friends. Okay, so this was all about the chapter. Now, friends, one request to you. The first thing, you need to solve the online test, which is of test 10 marks. Okay, and you will be not sending your marks, sir, on the group of our class. You'll be not sending, sir, I got 10 out of 10, I got 9, I got this, that. No, our group must be silent. Secondly, the assignment as like a homework to you. Okay, you have to write the answers over there. The marks for that will be 0. You have solved it in the last time also, last week. So do not have a complaint, sir, I got 0 marks, it's showing 0 marks. Yes, you have to fill the answers, the marks will be 0. And by chance, if you have a query, the third thing I'm going to tell you, if you have a query, kindly write down a personal message on WhatsApp to me. We all are familiar. Many times we share very good things with each other. So you can drop down a personal message, sir, please, my this answer, I'm not able to understand. We may discuss on that very easily. Okay, dear friends. So do not put anything on that group because there are a large number of messages. Okay. So let us take that one thing. And one more thing I would like to say to you, drink a lot of water every day to keep you fine, fit, happy. So once again, dear friends, this was the end of the chapter. We have seen all the things. Once again, I would like to give you best of luck for your studies. Again, surely, I'm very sure that within a few days, months, as per the rules, as per the rules of the government and the school, surely we'll be coming back very soon. I'll be very happy to see you all freshly, well prepared, happy. Yes, there has been a lot of that, but surely we'll be there, dear friends. Take care, study properly in a systematic way. Don't get tensed, be relaxed. And if you have any kind of difficulty, just text me personally. I'm there always to help you. So, dear friends, once again, wish you all the best. See you solve all your tests. And also, yes, very important instructions. The notes that I'm going to send, the job sheets, everything, you need to keep them safely, properly. Okay. Chalo, dear friends, once again, thank you everyone. Thank you very much.